Today we're talking about perfect square trinomials. So our first type of problem will be asked to factor. So when we're factoring x squared minus 14x plus 49, there are a couple of ways to do it. Some of you have learned an Xbox method, but with this particular problem, guess and check seems to be the easiest way. We just draw a couple of sets of parentheses. We know a binomial times a binomial will make our trinomial. And what are ways that we can get x squared? It's x by x. And ways to get 49 are pretty much 7 and 7. And we want those two numbers to add to become a negative 14, so they both have to be a minus. So x minus 7 times x minus 7, if we quickly distribute it out, is x squared minus 7x adds to the negative 14x, and then a plus 49 because a negative 7 times a negative 7 is a positive 49. We can also write this as x minus 7 quantity squared because this is a perfect square trinomial. It can be written as a binomial squared. If we look at this with an algebra tile format, we will see that we had x squared and then we had a total of 14 of those negative x's, 7 of them on one side and 7 of them on the other, and to fill in everything else we needed 49 little one tiles. So this is a perfect square. It has the same dimensions, x minus 7 and x minus 7, and made a perfect square, not a rectangle. For our second problem, we need to factor y squared plus 1/2 y plus 1/16. So, once again, we'll ask ourselves what are ways that we can multiply something together to get a y squared, and we're multiplying y by y. And we need to get factors of 1/16 that will add to become a positive 1/2. Well, factors of 1/16 are 1/4 times 1/4. Does 1/4 plus 1/4 add to become 1/2? Yes, so we need a 1/4 and a 1/4, and because we want them to add to become a positive, well, we want both of them to be positive, so this can be written as y plus 1/4 quantity squared, a binomial squared that, when multiplied, becomes a perfect square trinomial. One quick aside, ask yourself now, if you don't like working with fractions, would it have been better to be working with a problem like this? And chances are the answer is maybe not. We can recognize 5/10 is 1/2, but we aren't maybe quite as skilled at recognizing 625 thousandths is the same thing as 1/16. So your best practice is to keep things in fractional form. Our second type of problem that we'll be working with says we need to figure out what is the value that would make this a perfect square trinomial, and then we'll rewrite it as a perfect square. So we ask ourselves, if we had an x squared plus an 18x, what would we need to add to that to make it some binomial squared? We want to know it's going to be x plus what quantity squared. So when we are working with these kinds of problems, what we're actually doing is making a perfect square, and that means that we need to take that 18x and we have to split it evenly into two different places. Put half on one side, on the right side of our x squared tile, and half below. So half of 18 is 9. And so we take that 9 and we square it because we need 9 of these by 9 of these to get a total of 81 tiles in the middle. So 81 is our number that we are adding. Half of the middle term squared. So now this is a perfect square trinomial. It factors into x and x, plus plus because we have two positive signs, and 9 and 9, in other words, is x plus 9 quantity squared. Sometimes these problems won't be quite as nice. They won't be able to be modeled using algebra tiles because they're fractional to begin with, and we'll be working with some fractions coming up. So once again, we're going to ask ourselves, what is 1/2 of 5 halves? And then once we have that value, we will square it. So 1/2 of 5/2, 1 times 5 is 5, 2 times 2 is 4. So 5/4 squared, well, 5 squared is 25, 4 squared is 16. 25/16 is what we're adding in order to make this a perfect square trinomial that can be written as a binomial times itself. So when we factor this, the only way to get y squared is to take y times y, or y squared times 1, and then our factors of 25/16 are going to have to be 5/4 and 5/4, the square root of this guy, this value before we squared it. So we'll have a 5/4 in each spot, and because they're adding to become a positive, we want them both to be positive. So this is y plus 5/4 squared. And once again, it's better to work with fractions as opposed to decimals. Our third type of problem that we'll be working with is finding the vertex form of a quadratic equation by completing the square. In other words, we're trying to figure out what type of h and k that we're going to need to be able to find the vertex hk when x minus h squared is our perfect square trinomial written as a binomial squared. So the very first step is always going to be isolate the x squared and the x term, the first two terms. So we're going to subtract 6 from both sides, and y minus 9 will be equal to x squared minus 8x. Now we've got that x squared minus 8x, so we need to go in and change it so that we have a perfect square trinomial. That means those 8 tiles are going to be split evenly in half. So 1/2 of 8 is going to be 4, and when we square that 4, we're going to get a 16. So we're adding 16 to this side. But in order to balance an equation, before we were working with expressions, this is an equation. To balance that equation, we need to add that same value to both sides of the equation. So we're not changing the equation itself. And now a -9 and a +6 gets us y plus 7. And we have our perfect square trinomial. It is x, sign in the middle, and the square root of the last, quantity squared. Square root of the first, sign in the middle, square root of the last. And it's almost there. To get it in the vertex form, we want to move or subtract the 7 from both sides of the equation, so the y is isolated, so y is equal to x minus 4, quantity squared, minus 7. And we've found the vertex form of this equation. In our last example, we see that we have a leading coefficient. So still, we want to isolate those first 4 terms by adding 4 to both sides of the equation. And when we do that, we need to ask ourselves, how do we contend with this -2? So we don't want to take the greatest common factor out. We just want to take the leading coefficient and factor it out. So our y plus 4 hasn't changed. We're going to factor out a -2, and so if I divide the first term by a -2, I get an x squared. If I divide my second term by a -2, I will have a positive 5/2 x. And now the process is the same. We still have to take half of the middle term and square it. So if we take 5/2 times a half, and we square that, we'll have 5/4 squared, or 25/16. So if we add 25/16 to this side, the first thing we want to do is, typically we think, let's add 25/16 to the other side. But common mistake is made when that happens, because it's not really 25/16 that's being added to this side. It's a -2 times 25/16 that was added to the right side of the equation. So if I simplify that, 2 and 16 reduce, or simplify, sorry, to a negative 25/8, that was actually what I had subtracted from the right-hand side. So I need to subtract a negative 25/8 from the left side as well. So now we're ready to simplify or combine, and we have to write our 4 as eighths. So 4 times 8 is 32. 32 eighths minus 25 eighths is going to be equal to a negative 2. To save ourselves a step, let's go ahead and factor our perfect square trinomial. We did this by design, so it will be an x plus something squared. And what is that plus something? It's the 5/4, the number that we added before we squared it. And so a 32/8 minus a 25/8 is going to be a 7/8. So y plus 7/8. Try that again. Y plus 7/8 will be equal to a negative 2 times the binomial x plus 5/4 squared. To get the y by itself, we will subtract 7/8 from both sides, and there is our parabola, our quadratic equation in vertex form.